Hello, welcome to Chapter 9, Section 2/3. This is going to cover like a little bit of both sections. I reordered a little bit from our textbook just because I feel like it flows a little bit better. And funny story, I guess a couple years ago I made this video already, but I only made it because I was super sick that day, but I had to like stay on pace. So in the video, I sound awful because I had the flu. And so I decided not to use that video and make a new one for you guys. I love you that much. Okay, so in this video, we are going to be learning how to graph angles on the XY axis. So here's my graph. Here's our XY axis. This angle right here, starting from the x-axis up until this line right here, is 60 degrees. So this would be how I would graph 60 degrees. There's just a few vocabulary words that I want to make you aware of. So first is the origin. 0, 0 is called the vertex because it's like, when you make an angle, you have to have the two sides and the vertex. This length right here, the x-axis, is called the initial side. This is where we're always going to start our angle. So it always starts on the right side x-axis, and then we go up to whatever angle we want. Wherever it ends to make our angle, that's called the terminal side. So initial side, like, starting point, initial. Terminal, where it terminates. The terminator, where it like stops. So whenever we graph things like this is considered standard position. Let me give you another example. Let's say we're trying to graph 240 degrees. So we would always start right here on the x-axis. And then we know that if I went up this far, this line right here gives me 90 degrees. And if I kept going to this other side of the x-axis, now I'm at a total of 180 degrees, which makes sense because if you think back to geometry, 180 degrees made a straight line. And if I keep going all the way to the other end of the y-axis, that would be at 270 degrees because each of these corners is 90 degrees. So that would be too far though, because I'm only trying to go 240. So 240 is a little bit less than 270, and it's closer to 270 than it is to 180. So it's gonna be about here. And as we graph it, it doesn't have to be super exact. As long as I can tell, like, it's closer to the 270 line than it is to the 180, and so on. So that would be the graph of 240 degrees. You don't need this part right here where I kind of like do the swivel. It just kind of shows you like that's how far we traveled to get to the 240 degrees. But it's just this terminal side right there that you would really need. Okay, for my next example, I want to go and graph 500 degrees. Oh my goodness, it's such a big number. Okay, but again, we're always going to start on this x-axis right here. So as we go up, this would be 90, 180, 270, 360. So remember, if you go all the way around a circle, it's 360 degrees. So now we got to keep going again. So 360, we can add 90 again to get 450. And then if we go a little bit more, like 50 degrees more, then we would get to 500. So not quite at the 450 plus another 90 would be 540. So that'd be too far. But it'd be like here-ish. Because we went all the way around once. And that would be 500 degrees. Okay, for my next example, I wanted to graph negative 45 degrees. Oh my goodness, Miss Fernandez, what the heck? You can't go have negative angles. Just kidding. When we're graphing, we can do negatives. So you know how before we started on the x-axis on this side and we go up? Negative just means you go down. It's really exciting. So go down by 45 degrees. And that should be exactly halfway in between these two axes. So that's negative 45 degrees right there. Cool. Okay, I wanted to talk about another vocabulary word called coterminal angles. Coterminal just means that it's another angle, so it has a different degree measure, but it falls in the same spot when you graph it out. Okay, so let's do an example. the instructions will sound something like name a positive and negative coterminal angle to, and then whatever number. So I want to do 40 degrees. I've graphed it out here for you. So here's my 40-degree angle. So a coterminal angle would just mean that I would need another angle measure, but if I were to graph it out, it would lie in the same place. So like here, I went up by 40 degrees to get to this spot right here, or I could like go all the way around and then graph that angle. That would end up in the same spot as well. So what angle measure would that be where I would go 40 and then go all the way around again? So, normally when we go all the way around a circle, it's 360 degrees. So if I just add 360 to the 40 degrees, would give me 400 degrees. So 400 degrees, if I were to graph that out, would lie in the same spot as 40 degrees. So that's a coterminal angle. I can also go the opposite direction. So let's say I went, instead of going up first, I went down. So that would make our angle negative. Down and around this far would get me to the same spot again. And so that number, if I take the 40 and subtract 360 degrees from it, that would give me negative 320 degrees. And if I were to graph negative 320 degrees going down to get to negative 320, that would be in the same spot as well. So now I have a positive and a negative version that are both coterminal angles. There's actually an infinite amount of coterminal angles, so on your homework you can actually find as many as you want, even though they just asked for 2. Because if I took 400 and I added 360 again, that would get me to the same spot again, and that would be a new coterminal angle. Okay, so another example, let's say I'm trying to find a positive and negative coterminal angle to 600 degrees. So I've graphed it out here, here's 600. So if I add 360 to my 600 degrees, that'll give me a positive coterminal angle, which would end up being 960 degrees. Okay, cool. And then let's try to find a negative one. So let's subtract by 360. So if I took the 600 degrees and subtracted 360 from it, I would get 240, which is still positive. So that's not the negative coterminal angle that I'm looking for. So I'm going to take this number now and subtract it by 360 one more time. So when I did that, I got 240 minus 360 is negative 120. So now a positive and negative coterminal angle could be negative 120 and 240, or I could even do negative 120 and 960, whichever, as long as you have one positive, one negative. Okay, our last vocabulary word for this 2 sections is called a reference angle. So reference angles are the angle made with the x-axis, and it's like the closest x-axis that the angle is to, and it's that angle itself is always less than 90 degrees. So let's do a few examples here. So let's say we're looking at the angle 210 degrees. First, let's graph it out. So here's my graph of the angle. So going over 180 and then a little bit more. So first, this is the x-axis that's the closest to my angle. Not this one on the side, but this one right here. So I want to know this angle right here. That's my reference angle. So basically, how far off am I from this number? So when I went this way to this axis right here, that's 180 degrees. And then how much more did I have to travel to get to my 210? So if I do 210 minus 180, that means this is a 30-degree reference angle. Okay, another example, if I wanted to find the reference angle to 280 degrees, first off, I'd start by graphing it out. So 280 is a little bit past 270. Its closest x-axis is right here. Because see how it's on the right side of my axes? And the closest one would be on this side right here. So the reference angle would be this amount right here. So from this angle up until this x-axis, how far is that? So it looks like to get to 280, it was just a little bit past 270, like 10 degrees past 270. So that means the rest of this angle is 80 degrees. Another way you can think of it is that if I were to go all the way around, that would be 360 degrees. I could subtract 280 from that to get my reference angle as well. And so the method to find the reference angle is a little bit different depending on what quadrant you end up in. So if we do another example of 135 degrees, if I were to graph this, this ends up in quadrant 2. So remember, C for quadrant 1, 2, 3, 4. So in quadrant 2, the closest x-axis that would fall to would be this one right here. So I need to know this as my reference angle. And so if I do it this way, if I take, because this line right here is 180 degrees, 180 minus 135 will get me 45 degrees. So this angle right here is 45. And if you notice, all of So finally, I want to talk about trig functions of any angle. So we started with trig functions last section, but we kind of kept it simple with triangles, things like that. So now that we know how to graph angles, we're going to look at angles within a graph. So my example is going to be, let the point -9, -40 be a point on the terminal side of an angle. Find the 6 trig ratios of theta. So first, let's graph it. So if they say -9, -40 is a point on the terminal side of an angle, if I were to graph that out, we're going to estimate and pretend it's this point right here. So -9, -40. Well, it's saying that point is on the terminal side of an angle. So terminal side means that's the line that would make the angle, because that's a terminal side. So they're saying this point is on that line. So when we're talking about an angle and trig functions or trig ratios, we need to know the reference angle. So for this angle, the reference angle would be, the closest x-axis would be right here, the reference angle would be right here. That would be theta for us. So whenever they talk about the trig ratios of that theta, that would be the reference angle for it. So I'm going to use this point, the -9, -40, to draw, do you see a right triangle right here? That'll help me find all the 6 trig ratios. So the reason why I wanted a right triangle is because all our trig ratios have to do with a right triangle. I also know the length of this right triangle. That's also helpful because I know the coordinates of this point right here is -9, -40, which means I went to the left by -9 and then down by -40 in order to graph that point. So those are the sides of my triangle. I know they're negative, and so it's a little bit awkward, but that's how we're going to use them. Because this is a graph, we have to include negatives within our triangle. And so to find our 6 trig ratios, we also need the third side of our triangle in order to find like our opposite, adjacent, and hypotenuse. So let's use Pythagorean theorem to find our third side. So -9 squared plus -40 squared equals c squared. Okay, after doing Pythagorean theorem, I got c equals 41. So our hypotenuse is going to be 41. Your hypotenuse is always a positive number. So I know we just said your side lengths could be negative based on the coordinates that they give you, but your hypotenuse will always be positive. Okay, so now that we have all 3 sides, let's go ahead and do sine, cosine, tangent, and our cosecant, secant, and cotangent. So sine is opposite over hypotenuse. So if this is our angle right here, our reference angle, our opposite side is -40, hypotenuse is 41. Okay, cosine would be adjacent, which is the -9 over hypotenuse. Tangent is opposite over adjacent. So that would reduce to 40 over 9. And remember, cosecant, secant, and cotangent are just the flipped versions of sine, cosine, and tangent. So cosecant's going to end up being negative 41 over 40. Secant is negative 41 over 9. And cotangent is going to be 9 over 40. And just one thing, whenever you write your ratios for your trig ratios, this negative sign doesn't matter whether it's on top or bottom, because negative 40 over 41 is the same as the negative being attached to the 40 over the 41. When you divide as a ratio, you still get the same thing. In general, if we say R is going to stand for the hypotenuse, these ratios will always be how you find the trig ratios, where x and y are the x and y coordinates of the point. And that's it.